Hi, my name is Melody. Today I want to talk about theoretical yield and percent yield. Let's start to review first. What is theoretical yield and percent yield? The theoretical yield is the maximum possible mass of a product that can be made in a chemical reaction. Percent yield in chemistry is the ratio of the actual yield to the theoretical yield. The actual yield is the quantity of the product that is obtained from a chemical reaction. So here is the formula, which for how to calculate percent yield, which is actual yield divided by theoretical yield. Let's see some example. The first example is isolation of metals from ores. The original ores in nature are never pure substance, but always mixed with other metals. So the mass of ores used to calculate the yield is not the mass of iron in the ores. The next example is the production of ammonia. Ammonia is produced by mixing hydrogen and nitrogen. However, this reaction is a reversible reaction. The amount of ammonia produced could be affected by several factors, which in practice cannot be perfectly controlled. So why actual yield is always less than theoretical yield? There are a lot of reasons, but in usual, the actual yield is lower than the theoretical yield is because few reaction truly proceeds to compression, or because not all the product in a reaction is recovered, and the reaction is reversible reaction. This is three main reasons. So here is a diagram to explain what is limiting reagent and excess reagent. Make the hot dogs and bun combine in a 1:1 ratio. We can make 4 complete hot dogs. However, once we run out of buns, we will have to stop making complete hot dogs. In other words, the hot dog buns limit the number of complete hot dogs we can produce. So let's do some application. First, use the limiting reagent to calculate theoretical yield. Here's the question. A 3-gram sample of magnesium we add with 5.15 sample of oxygen according to the equation. So here is the equation. Here's the solution. So to solve this problem, we first need to determine which reactant, magnesium or oxygen, is limiting. We can do so by converting both react mass to the moles, and then using one or more moles ratio from the balance equation to identify the limiting reactants. From here, we can use the amount of limiting reactant to calculate the theoretical yield of MgO. So let's start by converting the mass of magnesium and oxygen to moles using their molar mass. So here is the calculation of the molar mass of magnesium and oxygen. And then in step 2 we find the limiting reagent. Now we know the quantity of magnesium and oxygen in mole. We can determine which reactant is limiting. We use the mole ratio between magnesium and oxygen to determine how much oxygen we would need to fully consume. Here is the calculation, which is 1.23 times negative power of 10, and then times 1 more, and then times 1 and 2 ratio, which is 0.06615 mole of oxygen. Then we compare the answer to the amount of oxygen. We can actually see if oxygen is limiting or not. And then according to our early calculation, we have 1.61 times negative power of 10 mole of oxygen, which less than 0.0615 mole. This is mean oxygen is limiting. And the next application is how to calculate the percent yield. Here is the question. A student makes 25 ml of 0.314 BaCl2 with excess AgNO3, causing AgCl to participate. The balance equation for the reaction is shown here. If a student isolates 1.82 gram of AgCl, what is the percent yield of the reaction? So, to determine the theoretical yield of AgCl, we first need to know how many mole of BaCl2 were consumed in the reaction. Now that we have the quantity of BaCl2 in mole, we can find the theoretical yield of AgCl in gram. So here is the calculation. We find the mole of BaCl2 first, which is 0.314, and then times the 25 ml, which is 7.85 times 3 negative power of 10. And then we use this one to times the ratio of AgCl and BaCl. Then we get the mass. In the end, we use the formula we learned, which is percent yield equals actual yield divided by theoretical yield, and then times 100%. We use the actual yield, and then this one is the theoretical yield, which is 1.85 gram of AgCl divided by 2.25 AgCl, and then times 100%, which and then we get the answer is 80.9%. Finally, we can get the answer of the percent yield. This is the reference, and thanks for listening.